Hello everyone, my name is Het Patel and here I am presenting our project on video streaming by using RTSP and RTP protocol. If I want to give the brief description about the RTSP and RTP, RTSP's full form is real-time streaming protocol and RTP is real-time transport protocol. RTSP is application layer protocol which controls the data flow from client to server and use the TCP or the UDP protocol, where RTP is the top of the UDP protocol, which basically the if the audio or the video signal encapsulated at the RTP packets, and these packets will be turned into the UDP segments. So RTSP is basically controlling the flowing of the data, and RTP is encapsulating the data. So this is the basic difference between the RTSP and RTP. Now, if we consider the Python code, that how the workflow of the data transport is working, here is the server side of the transferring. Basically, there are two types: server and client. Here, I am presenting the server side. So first, we are passing the argument uh, which serves the server port, and create by using this function the RTSP sockets will be created, and we are binding the server port with the RTSP socket, and then the client information will be accepted by the RTSP sockets while implementing this task. So if I run this code and initiating the RTSP port number to 1025, it will on the server. Here we can see that the server is on, and the real RTSP server working is described here. So there are basically four states uh, which are decided by these variables. Initially, the state of the server is init, and the four type of requests that can be sent to the server by the client, which are setup, play, pause, and tear down. We can see the diagram of these four requests is that if the server is in init state and the setup request has been sent by the client to server, the server will be in the ready state, and if the play request has been sent to the server, the server if the play request has been sent to server, the server will be in the playing state. If the tear down request has been sent, the server will automatically give to the init state whether it is in the ready state or playing state. So this workflow has been uh, described by the Python codes here. I will show you. So we are creating a thread for starting the client server transforming data. Initially, the setup state has been assigned to the server. If the request if the initially the init state has been assigned to the server, and if the setup request has been sent to the server, it will be directly in the ready state if there is no error occurring there. If the server is in a ready state and the play request has been sent to the server, then the server's state will be changed to playing if there is no error happening that. Then the pause and tear down request will be follow this type of scenarios. Then we can see that here the make RTP function has been created, which will have the data of the client and the server transforming. It will have basically the header of the data and the payload, which will have the data which are shown here, RTSP packet, that we are initiating the header size with 12, and the encode, decode, payload, and version, sequence number, times 12. These all functionalities are uh, initiated with the packet header size. And with that, we can say that the header considers with five type of data: the payload type, sequence number, timestamp, synchronized source information, and miscellaneous fields. These five type of data has been assigned with the header. uh, so all these functionalities will be work according to the task that has been given to them. So how the server will run by working these all functionalities, I will show them one by one. So first, here we are passing an argument with the with these four parameters. What are these four parameters is shown here. The first is server address, the second is server port, and third is RTP port, and four is file name. So here our server address is our PC's IP address. The server port number is 1025, which has been initialized earlier. The RTP port is 5, and we are streaming the file of movie.mjpg. So if I run this task, here a dialog box come here. So if I request a setup, we can see that here the sequence number is 1, and the RTSP 1.0 has version has been assigned here. And uh, further, if I request the play, the sequence number is increasing through thoroughly, because one by one packet has been transferred from the server to client. And every server will have a unique sequence number with assigned with them. If I pause this stream, the sequence number will be increased to 1. Before that, when I requested the play, the sequence number will be 2, and here is assigned to 3. And the data flowing has been paused for some time. And if I request the tear down, the sequence number will increase to 4. And well, what is the state of the server doesn't matter. The final stage will be in it, and the transferring the data will be stopped here. From this, the client side has been performed. So here we are starting the client side of the server client data transfer. These three variables will decide the state of the server as discussed earlier, and these three type of requests that can be sent by the client to server. Uh, the initialization phase is described here. The function will have some parameters inbuilt, and these parameters are used to uh, allocate values to variables which are described here. And these variables have been assigned with some values. And then uh, the user interface, which we have seen earlier, is created by using these functions. So there are basically four buttons: setup, play, pause, and tear down. These four buttons perform the work according to the functionality described here. So after every request, the sequence number is increased by 1, and it is also shown here that the column is increased 1. And after every request, the client will show what type of request that had been sent by the client. The setup between the client and the server will will be performed using this function. The state will be init, and then the connection will happen. The exit client function will assure that if the client want to close the connection between the server, it will send the request tear down, and the connection will be destroyed as seen here. The play movie and the listen RTP functions will be discussed further. Uh, then the connection to the server can be initialized by the two parameters which have passed here, the address and the port number. Uh, Here, the same procedure has been described. Then the sequence number is increasing with 1 after every request that had been sent by the client, and then the the outline will be shown by the server that which type of request have been sent. Then if whatever response that had been sent by the server, it will be encoded with some data there, and it will be shown by this print message that we can know that what type of data that has been requested and what data has been transferred by the server. Okay, so uh, okay, so whenever the connection has to be implemented between the client and the server will create a thread which will initiate the server's model that has going through connect to the client. So different threads are assigned with a different type of works that will be implemented, and the listen RTP function will initialize that if the late packet that is being transferred to the client or not. So here the frame number is the parameter which describes the late packet. If this the current frame number is greater than the frame number, then only the it will be accepted, and the listen RTP function will be performed by that, and tear down acknowledgement will be increased to 1, and the uh, connection will be closed at that time. Here for the socket binding, this function is initialized with the server address and the RTP port number, and after successfully implementing the binding, this message will be thrown out, and here we are exiting with the client and the server side. The implementation has already been performed earlier. So thank you very much.